Okay, good morning, everybody. Welcome to our workshop today. And welcome to the people that join us first time. I would like maybe to summarize what we have been doing during the last weeks. In April 9th and 16th, we covered the Caribbean Sea, the basins there. In April 23rd, we covered the Sinú San Jacinto Basin. In April 30, we covered the Chocó onshore. And last week on May 7th, we covered the lower Magdalena Valley Basin. Today, we have the pleasure to show you the middle Magdalena Basin. And next week, we are going to have the upper Magdalena Basin on May 21st. And in May 28th, we will cover the 6 areas in the Llanos Basin. And finally, closing this cycle number 1, we will cover the Pacific offshore areas. I just want to emphasize that beside the effort of the agency in promoting the 28 areas that we are revisiting every week, the invitation is to encourage you to nominate or incorporate areas in the gray area that you see in the land map of Colombia in open acreage. So the purpose of the agency is to encourage you to promote those areas in front of the investors or your investors to see that information, the data on those areas carefully and nominate areas. What we are doing in order to help you to make those decisions. The agency last semester promoted the studies called Play Fairway projects in frontier areas in Colombia. And as a result of that, we have these kind of maps. I mean, those kind of models of migration and charge in frontier areas. This is an example of the Sinú San Jacinto area and the lower Magdalena Basin, okay? And as you can see from this modeling done by the Universidad de Caldas, we have some basement heights here in this part of the Sinú San Jacinto basin, and here in the southern part of the lower Magdalena Basin. Well, the agency is going to provide this information to all of you, and also is going to show to you what data is available on those gray areas in order, to encourage you to buy that data and to elaborate the prospectivity on those areas in more detail. You can see here that the area that we were just looking at in the charge and migration model, you see the seismic there, the existing seismic there, as well as the existing of wells there on those basins. So that is our call. Please go ahead and look at that data that the agency is going to prepare every week and is going to present to you in order to promote the open acreage in Colombia at this time. With that purpose, we will start our cycle 2 on June 11th, and we will cover all those areas that you see on this map. In that order, we will cover the Cauca, the Caguán on June 18th, the Eastern Cordillera on June 25th, Catatumbo on July 2nd, Guajira July 9th, Guajira onshore on July 9th, Guajira offshore in July 16th, Tumaco and Putumayo July 23rd, Cesar Rancheria July 3rd. Today we have the pleasure, I'm going to talk about the presentation today, but let me just give you an update of what we are going to have next week. Next week we are going to have the upper Magdalena Basin that we will have Cesar Mora, our petroleum system expert in Colombia, starting the presentation that morning. We will have also the presentation titled Prospectivity of the Cenozoic from the Upper Magdalena Valley, and it's been done by the Universidad Nacional de Colombia under the Dr. Javier Guerrero direction. And later that morning, we will have the ANH experts, interpreters, giving you the areas where we think the major prospectivity is located and the illustration of the blocks offered by the agency. Today, we have the pleasure to present to you the Middle Magdalena area. We have the Cesar Mora talking about the petroleum system in the basin. And we have the Ivan Olaya. He is going to talk about this topic, a new tectonic province proposal and prospectivity of the Middle Magdalena Basin. And later, we will have Lina Serna, one of our interpreters, talking about the Colombia Round 21 Middle Magdalena Basin exploration opportunities. Let me give you some briefing of the background of the speaker this morning. We have Cesar Mora, geologist with more than 33 years of experience in basin analysis and prospect evaluation, play concept assessment, petroleum system modeling, petroleum geochemistry, and yet to find assessment. Cesar has been involved in regional studies in Colombia, Ecuador, Peru, Chile, and Mexico. And he has worked for Ecopetrol, Cipetrol, HEMS, and Cuenca. Cesar is also professor of petroleum geochemistry, and basin modeling in several universities in Colombia. We have the pleasure to have here Dr. Ivan Olaya. Ivan is graduated from the Universidad Industrial de Santander. He's a geologist, graduated in 1988. Master Science from the Colorado University. He's a Master Science in Geology. He also has a master, an MBA here in Colombia from the Universidad de los Andes in 2015. I'm sorry, I forgot to mention that Ivan is, he did his Master Science in 1997 and also an MBA in the Andes University in 2015. He has 31 years of experience working for 17 years for Ecopetrol, 2 years for Hocol, 8 years for Pacific Rubiales, and now he is currently an employee of Manzarobar, and he has been there with them for years. He is a very important professional in the industry. He is an invited professor from universities in Colombia, Peru, Ecuador, and Mexico. And we have also as a speaker today, Lina Serna, one of our ANH interpreters, geologist of the Universidad de Caldas, graduated in 2004. I'm sorry, I missed. I am talking about another Lina. 1 minute, please. Lina is a Master Science in Geophysicist, and currently she's working for the ANH. So I would like to welcome, well, before starting, let me mention that we have the chat here. You can address any questions to the chat, and we, the people that are behind the screen, we will be ready, and we will try to answer the questions as soon you send them. Okay, so use the chat, and we will try to reply to you immediately, if not at the end of the talk. I am not going to be here the entire presentation, but Daniel Rodriguez, one of the ANH interpreters that you have seen in previous talk, he's going to cover me, so he will close the talk today. Okay, welcome, and Cesar, please go ahead.
Gracias. Thank you, Miguel. Sorry, just a moment. I have a problem.
Well, let me just tell you that for the new people in this talk, in these workshops, don't forget that you can address our website, you can access our website, and you can see there all the presentations that have been given during those weeks, 5 in total, and you can also see the recording of each one. So don't hesitate to do that. As well for the companies that are unable to join us, don't forget that we have our data room available, and you can request any data room, presential data room anytime through the email dataroom@anh.gov.co. Okay, Cesar.
I'm sorry. Good morning, everyone. Today we will be talking about the petroleum systems of the Middle Mac. First, I want to thank the ANH for this opportunity, and we are going to start our talk with this. These are the topics we are going to talk. Something about the geologic setting, hydrocarbon occurrence, hydrocarbon potential, oil and gas geochemistry, and petroleum system modeling. And finally, we are going to close with the yet to find results. About the geological setting, we are located in the Middle Mac, but today we are going to talk just about the central and northern part of the basin. We are not including the southern part. Right now, Caldas University is doing a project there. Then we will be concentrated in this part where it's concentrated to the main oiling place of the basin. From the stratigraphic point of view, I want just to talk about the main sequence. We have the marine sequence from the Cretaceous section, Hauterivian maybe to Santonian. In this sequence, which is really very huge, we have the source rock. We have a very good distribution of the source rock interval. We are going to see that. And then we have a second sequence that are including the time maybe between Campanian to Paleocene, when we have a transition between the marine environments to the continental environments. And here we have units like Umir and Lizama formation. And finally, for the tertiary, we have the main reservoirs in the basin, and they are related with continental depositional environments. According to that, in general, we can see that the source rock are located and concentrated in the Cretaceous section, and the reservoirs are located mainly in the tertiary reservoirs. Another important point is related with the basement configuration. As you can see in this map, we have at least 3 huge depositors. We are calling these depositors Santa Lucia in the northern part of the basin, northern to the Cimitarra Fault. Then we have in the southern part, we have 2 more, the Nuevo Mundo depositors and San Fernando depositors. Between these 2 depositors, we have the Cachira Arch, which is a very, very important structure in the basin. in that area. We have one of the most important fields, oil fields in Colombia, La Cira Infanta. And at the end of the talk, we are going to talk a little bit again about this arch. From the structural point of view, you can see this section located in the central part. And here you can see that Cachira Arch is a huge structure that is involving the Cretaceous and the Tertiary sequence, and probably with a lot of hydrocarbon potential for the future in the basin. About the hydrocarbon occurrence, we have more than 80 fields in the basin. The biggest fields are located in the central part. Also, we have a lot of oil seeps, especially related with the foothills, with the thrust belt located to the eastern part of the basin, and also related with the west part of the basin, close to the heavy oil play that we have here in this part. Here we have the creaming curve of the basin. You can see that we can divide the exploration activity or the discoveries in the basin in two periods. The first one corresponds more or less to 52 years. And during that time, we found 30 fields and more than 78% of the oil in place. 14.5 billion of oil equivalent. Then we have the last 53 years, and we are changing completely the trend. And during these 53 years, we discovered just 30 fields, and the main problem is that we discovered just 22% of the oil in place. Another point that we really need to change in this basin is that here you can see that the last 15 years, during last 15 years, this is going to be flat, and which is not good for the basin. We need to change that. From the petroleum system point of view, we believe that we have a good opportunity to change again this curve and to find new oil in place. But probably to get that will be necessary to change the play concepts. And probably Ivan will be talking about that in the next talk. Now we are going to present a summary about the hydrocarbon potential. Here we have T mass from pyrolysis. We have S1 over S1 mass S2, production index, we have hydrogen index, we have TOC, and we have a potential, remaining potential. And you can see, in summarizing all this information, that we have world-class source rock intervals. We have so much samples coming from this well. We have here information from more than 35 wells. You can see very high levels of hydrogen content. Also, you can see a very high hydrocarbon carbon content in all these units. The green one corresponds to La Luna formation. We are dividing that unit in three members: Galembo, Punjamana, and Salada. And the orange one is related with the Aptian-Albian sequence that in the basin is called Tablazo formation. As one of the most important conclusions here is that we have a very good hydrocarbon potential in La Luna. Everyone knows that. But also we have a very, very good original hydrocarbon potential in Tablazo formation. Right now, this unit, this interval is unspent source rock. The hydrocarbon maturity level was very high, and right now we don't have too much potential, but the original one probably was higher in terms of hydrogen index, and carbon content was higher than the La Luna formation. This is very important for the basin, because we need to find a way, we need to find a way to find that oil, the oil that was generated and probably trapped from the Tablazo formation. According to kinetic models for these kind of phases, we are obviously in an oil-prone basin where 75% of the hydrocarbons correspond to liquid hydrocarbons, and 25 maybe corresponds to gas. This is important because we have a lot of oil, but because of the amount, the huge amount of generated hydrocarbons, also the amount of gas is very, very, very important. Now, we are going to talk about oil and gas geochemistry. What we have in terms of oil quality. Here you can see the relation between API gravity and sulfur content. You can see that this is a huge range for the API gravity. We have a huge variation in the API, and probably it is a result of a complex petroleum system charge that includes a first hydrocarbon pulse, a biodegraded process over that oils, and a second pulse, a refreshing oil that is changing the property of the oil in so many of the fields in the basin. Here we have the gas chromatography in order to show some examples that we have in the basin. This is coming from Lizama field. You can see that we have a lot of saturated hydrocarbons here. We have a very good oil, but here we have the evidence of the mixture. We have dimethylated opanes as a proof that this oil correspond to a mixture between a biodegraded oil and a refreshing one. Then we have La Sira, the main field in the basin. We have we can call this oil like a normal, but really it is not a normal. Was a biodegraded oil. You can see that we don't have saturates, but we have a refreshing with condensate. It is common in all the oils we can get from La Sira and from Infantas fields. The amount of this second pulse with condensates is controlling the API, the current API gravity. And finally, we have these kind of oils like Palagua, the heavy oils in the south part of the basin, where we have the biodegradation process. We don't have saturated hydrocarbons, but we don't have an evidence of the second pulse. We don't have the refresh. For that reason, in this case, the API gravity is still low, and we are really here in an area where we have heavy oils. In this graph, we can see a summary of the oil correlation. We are using these biomarkers, pristamphetain and C35, C34 opane, and you can see that most of the oils are located in the marine platform and the positional environment. Some of them are more calcareous in the organic phases, and others are more siliciclastic, but in general, these oils correspond to marine source rock, marine, and very, very similar to the phases we can define in La Luna formation, or even in some of the in the different members of the La Luna formation. Another important point in the basin is that for this group of oils that are located in the northern part of the basin and are located in Cretaceous reservoirs, we have a different oil family related with a more marine carbonatic depositional environment. We believe that this could be related with the generation expulsion processes from the Tablazo formation, from the Aptian, Albian soft rock intervals. And it's important to know, to say that the oil in place related with this oil family is really low. Then it is a frontier exploration target in the basin. We know we have that oils, we know that we have production in these kind of reservoirs, but most of this oil we don't see in the central and the southern part of the basin. Finally, talking about the gas geochemistry, you can see here using the relationship between ethane and propane and the isotopic composition of these gases, that most of the information, most of the data we have correspond to primary cracking. That means that gas is coming from the source rock and are located into the, or were generated into the oil window. We don't have secondary cracking like in the other basin, like Lower Mac or Guajira. Here, most of the gases correspond mainly with the oil window generation. In summary, we have an evidence of different source rock intervals. We have an evidence, a complex hydrocarbon charge system with a first pulse, a biodegradation processes, and a second pulse, a refreshing, including oils like this and oils like the condensates we have in the Kachira Arch. Now we are going to talk about a petroleum systems modeling. We have 1D and 3D modeling for the basin. Here you can see a burial history for the Santa Lucia Depot Center. Here you can see that the maximum burial depth was reached in late Miocene. It's related with the deposition of the Real Formation. And at that time, the Cretaceous source rock intervals got in some areas the gas window. Here we have the maturity level at the top of La Luna Formation, Galembo member. And you can see this area that is immature for the source rock interval. We have a huge area where La Luna Formation is into, or Galembo member, the upper one, is into the oil window. And also we have very huge areas for the gas window, especially in La Salina and San Fernando Depot Center. Here we are going to show some difference between the three members of La Luna Formation. We have really a change in this unit because the thickness is very important, it's high, then the maturity level is changing. From Galembo to Pujamana and Salada members, you can see how this gas window is getting bigger when you go from the Galembo to the Salada members. That means that we are going to have different contribution for oil and gas from this, for every one of these intervals. And it is important in terms of the jet to find for conventional, but also it is very, very important for unconventional potential for the unconventional oil or gas that we can retain into the source rock interval. Talking about that, this is just a way to present that. In the model, we can get this oil retained free in La Luna Formation, and you can see some difference, an importance difference. These colors are related with the amount of oil we can have by square kilometer. And you can see that the main amount is related with the Galembo member. It is, we have less oil in the Pujamana because different reasons. The main one, the original hydrocarbon potential. And also we have less oil retaining in Salada formation here because of the maturity level is getting up the expulsion efficiency. Then for that union in most of the basin was impossible to retain the same amount of oil that Galembo member was retained. That again, this model means that if you are talking about unconventional shale, oil shale and gas shale play in La Luna, you have to think a little bit which of these members will be your target, because the amount of oil retaining free will be different. And finally, I'm going to show up an example of the migration charge model. Here we are using a regional map for Mugrosa Formation, which is the main reservoir in the basin. And you can see the distribution of the migration pathways. You can see that not everywhere is related with a good migration patterns. But also a very important thing, thinking in complementary place, is to analyze a little bit the Kachira arch. In this model, we can reproduce the accumulation related with La Sira and Fantas. And even we can calculate a very close oil in place from the model. And also, we can see that we have preference migration pathways. In some of these A, B, and C, we have oil, commercial here, and non-commercial here. That in this kind of map could show us that we still have a lot of potential, but again, we have to change the play concept. If we are thinking in these kind of traps, like La Sira, Casabe, Llanito, the exploration target will be empty. But if we change the play concept, probably we are going to find a lot of oil. We have all the conditions for that. And finally, as a summary of the petroleum system, here we have our proposal. This is the event chart. And here we can see the potential of the basin. You can see that we have world-class soft rock intervals, one for the Aptian and one for the Turonian to Santonian. This corresponds to the anoxic global events. This is regional. This is part of a huge system in the planet. And also you can see that we have a lot of reservoirs. The main reservoirs are located in the tertiary, but also we have in the Paleocene, and also we have reservoirs in the Cretaceous. We have seals without a problem in all these units. And we have at least 3 periods of trap formation. The first one probably will be very good just for these kind of reservoirs, Cretaceous and Paleocene. But here, excuse me, related with the Middle Miocene and Pleistocene, we have a very good time. We know that because of the fields, because of the hydrocarbon charge, we know, but we have very good time. We have at least these 2 generation, migration, and accumulation time that correspond to these critical moments for the basin. Finally, about the yet to find. Because this is a mature basin, we did a fractal analysis and the result was this. 7.8 billion barrels for 14 new oil fields. It's a very good very good parabolic curve that has a very high correlation, 97%, and using mass balance calculation in a probabilistic approach, we are talking about more or less as prospective resource. Here we have geological risk involved, close to 7.7 billion barrels of oil equivalent. That means, according to this exercise, we have at least the option to find 50% of the oil in place that we found in the past. Okay, that's all we have. Thank you for your attention, and we will be checking the chat if you have any questions.
Okay, thank you, Cesar. I just want to say thank you to Miguel for the invitation to this talk. Today we will travel for the Middle Magdalena, and during the trip we will learn from the existing fields, and we will propose new prospectivity from that learned lesson from that field. Then, okay, let's start it. Okay, just a disclaimer, I just use public information. All the interpretation and the regional analysis are from my responsibility. And I know that some companies has additional information, confidential information that can modify my interpretation, but I don't have that information. And of course, the intention of this presentation is to give a regional prospectivity and no exact location for the prospect. Okay, the agenda for our talk today, we will start with a regional analysis, and then we will go to each of the tectonic provinces that we have in the Middle Magdalena to analyze the current prospectivity and proposing new prospectivity. That's the intention, that the objective of the today's talk. Let's start with the regional analysis. Here you have some of the plate types that we have in the Middle Magdalena. We have a structural, we will call this combined trap, because you have a structural and stratigraphic mechanisms for example, the Cartagallo field. Also, you have pure structural traps, as in the Provincia field. You have in the Cordillera field, you have mainly stratigraphic traps, and also in the Velázquez field, you also have stratigraphic and structural mechanisms, and we will call this a combined trap. Then let's move to the, okay, to be in context, I will mention some formations. Then I will call the Esmeraldas La Paz formation related to the Eocene, and Mugrosa related to the Oligocene, and Colorado related to upper Oligocene and probably lower Miocene formation. And of course, the La Luna and Umir and Lizama, I will refer with the upper Cretaceous, mainly the Umir and Lizama, Lisames Paleocene, okay. And the La Luna formation as the main, as Cesar mentioned, is the main salt rock in the Earth. The tectonic provinces that currently we have in the middle map are shown in this map, in this slide. You can see that the tectonic provinces are mainly south-north trend. And when you analyze the regional geologic surface geologic map, you can see some alignments that I will put in this map. Look at it. For example, this alignment associated with this black line, and look at that. You have some strange configuration here in this area, and look at that in the Cordillera. Also, you have a different rocks from this point to the north, from this point to the south. Doesn't matter what are that rocks are different from that point to the north, respect with the south. Okay, that's interesting. Look at the alignment that I put there, and look at that. From that alignment to the north, you have several alignments in the same trend. I mean, south, west to northeast trends, and producing like a compartments between these northern zone. Another alignment that I want just to point out is this alignment that you have here. Look at that. In that alignment, there is a change in the behavior or in the structural behavior in the Cordillera. Look at that. You also have change in this part of the basin, and we will see that this feature will correspond with the last or the finish of the Cretaceous from the north to the south. Another interesting feature in the middle map. Look at this feature here. In this area, the Ronda thrust finished suddenly in this here, and look at that. There is a change in the structural pattern in the Cordillera in this section. We will see this in detail later, but just to have the main features, the regional main features in the basin, and of course this alignment that is associated with the limit of the foothills in the basin. That means I will talk about 5 structural or tectonic provinces in the basin. A north zone from this alignment to the north. A central east zone that is associated with the Las Irifantas and other fields. The west central zone that is associated with the Velázquez, Palagua, Caipal, and Nare fields. Of course, the foothills that is associated with the Provincia, Lizama, Opon, and Buffalo fields, and the south zones that is associated with the Puli, Toki, Mana, and all the fields that are located in the southern part. Then you can say, okay, that feature, that alignments can be related with a shallow, the shallow section in the basin. Then I went deeper. I took the map, the subcrop map below the Eocene and conformity in the middle map, and I put exactly the same alignment that I saw in the surface geological map. Look at that. In this case, this alignment can be associated with an alignment or a fall that was mapped in this map. This is the source of the author of this map is the ANH, and Look at that. Again, you can have several southwest northeast alignments parallel to this main feature that we identified in this area. Again, look at this feature here, this alignment here. Look at that. Is marking the end of the or is associated with the finish of the Cretaceous formations to the south in this point. Interesting. We will see what is the meaning of that, the geological meaning of that feature. As I mentioned before, this feature that is located southern, immediately south of the Velázquez and Nare formation is associated with a different trend in the Eastern Cordillera, and of course the foothills, this alignment that is separating or dividing the basin in the east zone, that is we will call that the foothills, and the west part of the basin. I took the same map from another author, from the ICP during the 90s. Look at that map has more detail than the ANH, and look at that I put there the same alignments that I saw in the two previous maps. Look at that here. Again, you can see a different trend from the northern of this alignment and the southern part. Look at that. As Cesar mentioned it, the Cachira High that has a south-north trend doesn't or disappear northern of this alignment. Interesting. We will see what is the prospectivity, or what is the consequence in the prospectivity from this alignment in the basin. And of course, a lot of alignments parallel to this main alignment in the northern part of the basin. Again, this alignment that is showing the end of the Cretaceous rocks to the south in the basin, and of course the foothills. This alignment that is separating the foothill from the basin. Okay, that's two maps, different, and you can say, okay, it's a coincidence. Then I went deeper. I took the La Luna structural map for the ICP during the 90s, and I put again the same alignment. And look at that. You can see clearly that there is a different pattern, different structural pattern from this alignment to the south and to the north. We will see later what is the consequence in the prospectivity of that alignment. And again, look at the trend, the alignments and the faults that have the same trend. I mean, southwest northeast in the northern part, and the foothills, and look at this alignment that is showing again the finish of the Cretaceous in the northern part and the southern part. I went deeper. I took the Rosa Blanca structural map, and I did the same. Look at the same alignment is showing again the end to the north of the Cachira High, and it's showing and it's beginning the southwest northeast trend in the northern part. We will see the prospectivity of this fall later, and again the end of the Cretaceous rock to the south. Okay, that is interesting. a new tectonic division, the tectonic provinces proposal in the basin. And then I took that new proposal and I put in several maps. I put, for example, in the oil families map. And look at that. Easy, you can see a different oil families from the southern from this alignment, in the southern part of this alignment and in the northern part of this alignment. And again, the different or the alignments parallel to this main alignment are producing different families in the northern part. Look at that. This alignment that is associated with the end of the salt rock to the south is also limiting the oil family, the sea oil family, and of course all the foothills has a different family than the previous one. Okay, then I took another map and I put the same alignment. Look at that. In this map, there are a lot of oil seeps in the Cordillera in this part. Look at that. Okay, we will analyze the oil fields in this area later. Look at that. The main active pod is below the Elizama and in the southern part of La Sierra Infantas. The naphtha well was drilled here, got more than 20,000, almost 21,000 feet, and didn't reach the base of the Mugrosa. I mean, it's a huge pod in this area. Look at that. Look at that. The trend in the Cordillera. This fall that is the Honda trough finish here, and this alignment is associated with that change in the Cordillera in this point. Look at that. There are several oil seeps in this area, and look at that. This alignment is separated. A huge zone with oil seeps against the central Cordillera in this area, and has a different behavior, a different pattern in the northern part of this alignment. Interesting. Okay, and of course the foothills has a different configuration than the previous one. Look at that. For example, let's analyze just one family, the oil family A and the oil family B. If the pod that the generation pod is located in the southern part, you have a migration from south to north. That means that the oil family is farther than the B family from the pod. My limited geochemical knowledge told me that, or tell me that the oil family is farther away than the pod, have to have a lower API gravity, but that's not the case. Look at that. The A family has 35 degrees API, and the B family has 23. Something is wrong here. Probably there is another pod in the northern part of the middle Magdalena. That requires more analysis. I also took the gravity map and put my alignments, and look at that. This is from ISS. Look at that. There is a very strange feature in the middle of the middle Magdalena in this area, and it's associated at that feature that I am identifying or showing in this sector. Interesting. Also in the well seeps map, you also have, again, look at that, especially in the south, you have a different pattern in this area. compared with this area, with the Velázquez, I will call this the west central area. Okay, what is the geological meaning of that alignment, or that feature that I am identifying in the basin? When I try to answer that question, I remember my friend Luis Fernando Sarmiento PhD thesis, and look at I put these two maps at the same scales, trying to imagine, trying to say what is the geological meaning of the feature that I am identifying in the basin. Then look at that. Luis Fernando identified three main features, west-east approximately. One is this is the northern limit of the Tablazo Magdalena subbasin. The other one is associated with this transverse paleofault, and the last one is the Nazareth paleofault. Then, when I put at the same scale that features in my map, look at that. Probably this feature is associated with the limit of the Cretaceous in the middle map. It's associated also with this feature here that produce the end of the Honda thrust in this area, and another feature that we will see later in the southern part that is associated with the Eocene overlap in this part. Okay, with that analysis, let's start analyzing each tectonic zone and looking for new prospectivity. Then let's start from north to south. This is the most northern seismic lines in the basin. Look at that. In this area, you have a lot of faults in the Cretaceous that do not cross the Eocene nonconformity. I mean, you have, of course, you have some of them that are very recent, but most of them has not are just present in the Cretaceous section. Then move southern, and we in this regional section, you can see again that you have faults that are concentrated in the Cretaceous section. I mean, below the Eocene nonconformity, as some of them are associated with the more recent movements. I just want to point out the Buturama field located in this section. The Buturama field was discovered during the 70s, and look at the key point here is look at that the migration pathway is coming from the southeast in the look at do you remember that the main pods are located in this section, in this part of the basin? That means the oil migration pathway come from in your screen from right to left, and the Buturama is located in the right side, I mean in the east side of this fault. The Buturama, I will show you the results of the Buturama, but later, but I just want to point out here that the wells that are located in the west side of the faults in this northern section are mainly dry. I mean, most of them are dry. And the wells located in the east part or in the east flank of the sections are oil producers. Have in mind that sentence. Look at the detail of Buturama. Look at Buturama, Olivo, and Catalina. Catalina, look at the Catalina was mainly navigating along the Rosa Blanca formation. Olivo was navigated along the Salto limestone, and the Buturama was a vertical well, mainly producing from La Luna and also from Rosa Blanca. We will call this the basal limestone group. And look at the results. Olivo 1 from the well history. Olivo 1, 5,000 barrels per day, 14 degrees, and Catalina 1, 7.5 thousand barrels per day, 38 degrees. Have in mind these values. I mean, the 5,000 and the 14 degrees. Look at that. Show are different AP gravities. I don't know why. Probably Cesar had the answer to that. And that was during the 70s, probably 80s. And you say, okay, but that's really all. Last month, Parex drilled a well called Cayena in this section, in this tectonic zone, and did also got production from the horizontal section in the Galembo and in the Galembo formation or member from the La Luna. This is taken from the parent web page, and look at that. Also, they have good production, 242 barrels per day, more than 30 APA degrees, and this is the most important. No water, less than 1%. Interesting. That means Parex is learning lesson from Buturama, from Olivo, from Catalina. Going south, you have the Los Angeles and Tisquirama fields. Again, look at that. The most of the falls do not cross the Eocene unconformity. I mean, I concentrated in the Cretaceous section. Again, the oil migration pathway come from in your screen from right to left, and that means you have a really huge structure in this section, in this part of the basin. Los Angeles and Tisquirama has production from the Lizama formation. I mean, from the upper Cretaceous section, but probably if you try, you will have also production in the deeper part of the Tisquirama associated with La Luna formation in this section, as Buturama. This is a good place, a good section, a good place to drill for oil production similar to Buturama in the La Luna formation. I just want to point out the Eocene potential here. Look at that. This is the Eocene unconformity. Look at the overlap of the Eocene section in the central part of this, and we will see later that Boranda and Flamencos discoveries are associated with the pinch out, with the overlap of that Eocene section in the southern part of the basin. That means we also have a stratigraphic potential in the Eocene section in this part of the basin. Let's move down. Here you have again Los Angeles, and here you have the Mono Araña structure. Look at that. The Mono Araña, and the Osopardo discovered produced from the Lizama formation. I mean, the Lizama was not a conventional or a normal reservoir in the basin during the last century. During the last 10, 12 years, Lizama was considered one of the reservoirs in the basin because we have also Pardo discovery, Mono Araña, Acordeonero, and another discovery that we will see later. Look at that, the structural configuration of Mono Araña the Lizama is truncated by the Eocene unconformity. We will see later that Acordeonero is exactly the same plane, and that generates that or that produces that there is a play associated with the Lizama truncation in all the basin to the south. And also again, look at that the Eocene overlap in some places. In this, that's the additional stratigraphic prospectivity in the basin. Mono Araña is also producing from the Lizama from two levels, the upper Lizama and in the lower or middle Lizama, and they are producing 20 degrees API. Is a medium. It's a really good gravity. And look at all the recent discoveries in the basin in this part of the in the northern part of the basin. Look at the Acordeonero, Boranda. We will talk later from Boranda, Cahuí, and Colón. Let's see what is the prospectivity from oh, okay. Let's analyze also Acordeonero. Look at that the Acordeonero is also the erosional truncation of the Lizama formation against the Eocene unconformity. Okay, then we learned the lesson. The Lizama is truncated with the Eocene unconformity can be a potential trap. Look at Boranda. Boranda is a interesting discovery by Ecopetrol. Is the overlap of the overlap of the Eocene unconformity, the Eocene strata against the Eocene unconformity. Look at that. Here you have the Boranda discovery, and probably you have also a future West Boranda discovery in this section, because look at this is more or less the same parent, the same overlap in this part of the basin. Then, and of course you have the oil migration pathway from right to left. Here we have Cahuí. Okay, you will say, Ivan, Cahuí is dry. Yes, I know that Cahuí is dry, but I just want to point out this section from in the right side of Cahuí. This reflector is the Eocene unconformity, and look at that the Eocene section is present in this part of the structure, but is not present in the upper part of the structure. I mean, this is a bowl high. In Spanish, we call that un alto calvo. Claro? Then there is an additional prospectivity associated. Applying the lesson learned from Boranda, you have potential in the Eocene sequence in this part of the basin, and you have the perfect trap in this section. Okay, additional prospectivity. Altos calvos. They are a lot in the middle map. Look at the overlap of the Eocene, similar to the Boranda discovery. Okay. Now, flamenco discovery. Look at that. Flamencos is here. Look at that. You have here the Eocene unconformity. You have Eocene sequence. The oil migration is from right to left. And look at the plate type of flamencos. It's again, as Boranda, they pinch out the overlap of the Eocene sequence against the Eocene unconformity. Easy stratigraphic traps, and we have a lot of these configurations in the middle Magdalena basin. Okay, until here you can say, okay, Ivan, that's it. You have a good ideas. That's a good hypothesis. Could you apply that lesson learned in the previous or in these fields in the blogs that the ANH is offering in the 2021 round? Okay, I say, okay, look at this is the block BMM 28 that is being offered by the ANH. And I took this section from the data pack, and the ANH is offering interesting structure in this area. But I just want to point out your attention in this fall. Look at that the seismic response in the right part, in the right side, is different to the left side. That means that can be associated with a strike slip movement along this fault. And look at that. The seismic line is located here. It can be that fault is associated at that huge alignment that you have in the middle map. For me, that alignment has a strike slip movement. Then applying the learned lesson from Futurama. Why not? If the oil migration is coming from right to left, why not to have a prospect similar to Futurama fields, to Olivo fields, to Catalina fields, looking accumulation in the upper part of Cretaceous, in the La Luna, and also in the basal calcareous group. That's a good analogy for Futurama, for Olivo, for Catalina. Remember, 7,000 barrels per day. Huh? Why not? Okay, let's move to the other. Wow, the time is running too fast. Let's move to the other tectonic provinces in the basin and looking for new prospectivity. This is a regional section showing. Look at the interesting point. Here you have that huge, or that main alignment that I showed in the maps before. That means you have the northern zone in the left part of the section. You have here that alignment. Look at that. That alignment is associated with this important fault. And to me, that fault also has a strike slip. And that fault is, you have several oil fields aligning with that fault. You have it, Casabe, Lizama, Llanito, Gala, Galan. Wow, you have several faults perpendicular to the screen in this point. In the Northern Sea, you saw the flamenco discovery projected more or less here. Look at that. In the central east zone, the structural behavior is different than the northern zone that we saw before. Look at that. Most of the faults has a recent moments, and of course, La Sierra field is located in the central part of this Cachera High. But look at that. If the oil is migrating from right to left, all these faults can be a traps, or can be a prospective trust for future discoveries. But Ecopetrol did several discoveries in this area. Look at the arrows. You have here also, as in Boranda, as in Flamencos, on lap of the Cretaceous. And also you have here, as in Cacordionero, as in Monoraña, as in Oso Pardo, the erosion and truncation of the upper Cretaceous against the Eocene and Confortine. An additional trap similar to the previous or to the recent discoveries in the northern part of the basin. Ecopetrol did several discoveries recently in this area. Is Infantas, Oriente, and Coyote. Both are associated in has oil discoveries in the tertiary section in this area. But let me show you something. Let me show you this line. This is east-west, northwest, southeast line. And I just want to point out your attention in this part. Look at that. That was my interpretation in the ICP during the 90s. Look at, this is more or less approximately the top of the La Luna formation. This is the top of the La Luna formation. But look at the structural behavior or the geometry below the La Luna top in this part of the section, and look at this huge structure here. If you have, if the La Luna is here, that means you have really all structure in this part of the basin. That means what? That means that yes, you have Ecopetrol has recent discovery here in the tertiary section. I mean, from this point to above of the upper Eocene and Confortine. If you want additional discoveries in this part of the basin, that is, this is the BMM 59 block in the current 2021 round. You have to go deeper. You have to go to the Cretaceous, and you will get new oil accumulations in this part of the basin. Okay, let's move to the foothills. That is easy because the traps are mainly structural. Look at the Provincia field. The more or less the limit from the east central zone is the front fall from these foothill zones. Again the oil is migrating from a kitchen in some place here to the left. That, yeah, and the Provincia is located in a really good position for that migration path. Again, look at the arrows here. You have in the footwall zone, you have Eocene onla, and you have upper Eocene, upper Cretaceous erosional truncation, similar to Ronda and similar to Cordillera. Interesting. This is Las Monas. Look at that. In the Las Monas field, Las Monas anticline or Las Monas structure, again, Eocene onla, and a lot of let me show you a detail. Look at this is the Las Monas anticline. This is a sequence analysis, sequence stratigraphy analysis, and showing that the age of this structure was really old, was at least Eocene. Look at that. During the Eocene, you have onla, you have some progradation in the upper Eocene. You have in the Murosa, you have another pulse, another uplift pulse. Look at that. You have the erosion in this part, and during the Miocene, you have also the last or the most recent movement. That means it's a multi-phase structure, and the Eocene age is good because it's associated with a really good timing in the petroleum systems. Okay, let's move to the south. Upon field is also a gas field producing from the Eocene, La Paz and Esmeraldas formations. And here you have Buffalo. Buffalo was a recent discovery from Ecopetrol. And I just want to point out this one. Crude from 30 to 35 degrees and dry gas in the same structure. Let's analyze how is buffalo. Buffalo has in the hanging wall oil of 35 degrees, and in the foot wall dry gas. Clearly, both hydrocarbon types come from different pots, different kitchens. The dry gas you need more than one bitumen refractant, so more than one, and the 35 degrees oil you need less than one. I mean, both you have two different oil types coming from two different pots or different times of that pot. But this is a really interesting structure, and we need more analysis, more studies to explain why we have different hydrocarbon types in this discovery. Let's go to the Central West Zone because I just have 10 minutes. In the West Central Zone, we have the Velázquez field that is 28 degrees. We have Teca and Nare fields that are 12 to 14 degrees. And look at that, the play in this area are more associated with the normal faults. In this area, different to the previous one. Here you don't have Cretaceous. Here you don't have that southwest northeast alignments associated with the strike slip. Here you don't have that spectacular anticlines as in Provincia and Ceramona. You have a small normal faults, and also look at the model for Velázquez. You have the plate type is associated with that normal fault, but also associated with the onlap of the tertiary section, mainly Mugrosa and Colorado in the west part. You also can have potential for in this section for that stratigraphic troughs. A detail showing the troughs in this part of the basin. Look at normal faults as in Velázquez, as in Palagua, as in Caipal, as in Nare, as in Teca, and also additional prospectivity associated with onlaps, stratigraphic onlaps, as in Boranda, as in Flamencos, in this part of the basin. Okay, let's move to the south zone. I have just 5 minutes. This is a west-east section showing that you don't have here too much faults. You don't have too much structuration in this part of the basin. But I just want to look at to point out your attention in this part of this map, the surface map. Look at that. In the Honda thrust is coming from south to north, and in this section, in this part of the basin, you don't have the continuity of that thrust. And also look at that, the Dos Hermanos thrust is coming from north to south, and it's not present in this part of the basin. That's good for what? That's good for, because if we are saying that the generation pot is below the Cordillera, there is a easiest migration path in this section, in this part of the basin, than in the south and in the northern part. Because what I'm saying, look at that, probably you have oil migration from the generation pot in the Cordillera, from east to west, migrating in an easiest way, than in the southern and in the northern part, because you don't have here thrusts that are limiting the oil migration from east to west. Interesting. Is that the reason why we have a lot of oil in this part of the basin and not oil in the southern part of the basin? I don't know. We need additional analysis for that. Look at this. This section is a south-north section in this south zone. Look at in the that was the author of that was the ICP during the 90s. And look at, I just want to point out this fall here. Look at that in the southern part, you have Eocene and you have more, we call that the sedimentary basement. And from this point to the north, you have more another type of basement, and you don't have Eocene in the from north of this fault. What is important of that? Eocene is the producing section in the southern part in Mani, Toki, and the fields located in the southern part of the Middle Mag. What is the meaning, the geological meaning of this fault? Do you remember the map from Sarmiento? Look at that. That fault is probably the southern or that Nazareth Paleo fault that Luis Fernando Sarmiento is proposing in his PhD thesis. Is this one, and that has important consequence in the prospectivity from this point to the south and from this point to the north. Finally, in the southern part of the Middle Mag, we have several fields like Totare, Ambrosia, okay, Toki, Puli, Riopia, and look at that in the foothill section, in the foothill sector. You have mainly the Puli field, you have mainly gas fields, and in the foreland, you have Mana, Riopia field that are producing from Doima and Chicoral formations, mainly Eocene. And when you are moving to the west, you have production from, in the Totare field, you have production from Quaternary or from the Ronda formation. I mean, if you are moving from east to west, you are your reservoirs are being younger from Cretaceous, Upper Cretaceous, the Montserrat formation to Ronda in Totare. Okay, 2 minutes. Okay, conclusions and prospectivity. New ideas for all basins. I mean, I am proposing here new tectonic provinces in the Middle Mag. I am proposing here why lesson learning from existing fields as Buturama, as Acordeonero, as Boranda, as Flamenco. You can apply the same play or the same concept in the southern or in another parts of the basins or the Middle Magdalena basin. The new tectonic provinces that I'm proposing need more more analysis, more detail, and what are the consequences of that new tectonic provinces. And we need more information. We need multidisciplinary studies to really understand better what is the tectonic stratigraphic model in some of these new tectonic provinces. Of course, this proposal has consequence in the hydrocarbon prospectivity. Let's analyze each area. What is the current and the new prospectivity that I am proposing in this area? For example, in the northern zone, we have existing structural traps in Cretaceous limestones, as in Buturama, Olivo, Cayena, the most recent discovery from Parks. Also, structural traps in the upper Cretaceous, Paleocene, I mean, Lizama formation, as in Acordeonero, Monoaraña, etc. And we have a lot of similar configurations in several parts of the basin. And also, we have, in the northern part, we have stratigraphic traps, mainly in tertiary, mainly in Eocene, as in Boranda, as in Flamencos. Okay, we can consider Yariquí Cantagallo as a structural trap because it's the pinch out of the Eocene against the Central Cordillera. In the central east zone, in this moment, we have structural traps, mainly in tertiary, associated with La Sierra, Infantas, Aguas Blancas, Colorado. The most recent discoveries as Coyote, Infantas Oriente, but we also have new places in this area associated with structural traps in Cretaceous and in Paleocene as in the northern zone, and also new place in stratigraphic traps in tertiary as in Boranda, as in Flamencos. But we need 3D surveys to discover these traps, these stratigraphic and structural traps. That doesn't matter. You need new 3D information. In the west central zone, we have in this moment structural traps associated with Velázquez, Palagua, Caipal, Nare, Teca, Cocorná. New place in this zone I'm proposing stratigraphic traps. In tertiary, remember that here we don't have Cretaceous strata, but also we need 3D with enough resolution. I mean, with enough resolution, that means frequency content higher than 50, 60, 70 hertz, because the current stratigraphic, the current 3D surveys there has like a 30 hertz average in frequency content, really low to do a stratigraphic analysis from that information. In the foothills, in this moment, we have structural traps mainly. In tertiary, as in Provincia, Opón, Las Monas, Búfalo, etc. In the upper Cretaceous and Paleocene, as in the Lizama field, in La Tigra, Tesoro, Peroles, probably. But there is a new play that was discovered by Buffalo. In the foothill of the Tross, you also probably has accumulation from, and probably as in Buffalo, you have in the hiking wall you have a one petroleum system, and in the footwall you have another petroleum system. That's the Buffalo need more analysis. And in the southern zone, in this moment you have stratigraphic traps, as in tertiary mainly, as in Maná, Toki, in upper Cretaceous and Paleocene, as in Puli. But we have the potential for new traps in stratigraphic traps, mainly in the tertiary section. Also, as in the previous one, we need a 3D surveys to do a detailed analysis of the stratigraphic model from the zone. Okay, that's all. Thank you for your attention. That's my email. If you want this presentation, I will send you. I don't know if Lina. Okay, thank you, Lina. Is your time?
Good morning. Can you see my screen?
Yes.
Okay. Good morning. This is Colombia round 2021 for the Mirror Magdalena Bailey Basin. It's a part of the round, and we can see the exploratory opportunities identified in different blocks. The content of this presentation consists, first of all, an introduction where I will show you the location of the blocks offered in the Colombia round. Afterwards, some general aspects as infrastructure and geological framework. Next, the database, where summary, seismic interpretation, and finally, the prospectivity of the areas and conclusions. That's the introduction. The first part of the introduction is the location. For the Colombia round 2021, the ANH is offering 3 areas. The areas are BMM 19A1, BMM 28A1, and BMM 59. This area, BMM 19A1 block, has more than 100,000 hectares in area, and it is located between Bolivar and Cesar and Magdalena departments. This area is located in the northern part of the lower Magdalena Basin and middle Magdalena. The BMM 28A1 block has 24,600 hectares in area and is in Bolivar and Santander departments. And the BMM 59 has more than 89,000 hectares and it is located in the department of Santander. As main infrastructure nearby to the blocks, the basin has different oil pipelines as Caño Limón Coveñas, Ayacucho Coveñas, Proyecto Bicentenario, and ODC or Oleoducto de Colombia. The main pipelines are Galán Ayacucho and Poliducto de Oriente. The main gas pipelines are Galán Ayacucho and Gasoducto de Centro Oriente. The stars indicate the different stations associated to those facilities. The geological framework, the Middle Magdalena Basin is considered a continental bank arc, later became Intermontane Basin, separating the 2 eastern branches of the Colombian Andes, the Central Cordillera to the west and the Eastern Cordillera. The structural boundaries are taken this figure from volume 11 of ANH. The limits or the boundaries are to the north, Espiritu Santo fault system, northeast, Caramanga Santa Marta fault system, to the southeast, Bituima and La Salina, to the south, Girardot fault belt, and to the west, the onlap of neogene sediments over the Serranía de San Lucas and Central Cordillera basement. The 3 blocks offered by the ANH are located in different structural domains, defined by Córdoba in 2001, by taken in ANH to 2011. The BMM 91, this block is the northern, in the most northern part of the basin, is located in the northwestern domain. The northwestern domain is characterized by a wide, east dipping homocline with north-northeast trending, transtensional normal faults with dextral oblique displacement, and fault planes dipping toward the east-southeast. These faults show partial inversion towards the east, close to the Eastern Cordillera Basin, where they have compressional and dextral strike slip components. The BMM 28-1 block is also located in this structural domain, in northwestern domain. And the BMM 59 is located between central domain and foothills domain. The central domain is characterized by opposite convergence of troughs and fault belts, forming a structural convergence zone resulting from 2 deformation events, late Cretaceous to early Eocene compressive to dextral transpressive deformation, related to the Central Cordillera. and Cenozoic compressive to transpressive deformation were related to the western flank of the Eastern Cordillera Basin. The foothills domain basin is from Eastern Cordillera, is characterized by West Virgin thrusts and faults resulting from Cenozoic compressive to transpressive deformation related to the western flank of the Eastern Cordillera Basin. In the stratigraphic of the Middle Magdalena Basin, the sedimentary record shows a succession of Jurassic continent deposits overlaid by Cretaceous sediments, both calcareous and siliciclastic of transitional to marine origin. The tertiary sequence is made up of 4 siliciclastic rocks deposited mainly under continental conditions as alluvial fans and fluvial bodies with some marine influence. The tertiary units as Mugrosa, Colorado, Mugrosa, Esmeraldas, and La Paz formations have been considered the main reservoirs in the area. But all the rocks have had significant discoveries as in Lizama Formation and La Luna and Rosa Blanca formations. As occurs in the northern part of the basin because the Paleogene is eroded in this basin sector. La Luna Formation is the main source in the area that Cretaceous limestones and shapes of the Simitita-Blazo formations are also source rocks in the basin. TOC are high, between 1 to 6%, and organic matter is mainly tied to biotrinite reflectines reaches values of 0.6 to 1.2%. The database, first of all, we start with the block located in the northern part of the basin. The block is BMA 19.1. This is considered as an emergent area because of the data limitation and its location in the basin. In the area, there are 4 seismic surveys acquired from 1989 to 2015 that up to a length of 72.46 kilometers within the area. The seismic survey Pailitas 2D, corresponding to these purple lines, was acquired by the ANH in 2015 through vibro size technique. The other lines, as Ayacucho and Bolivar, cover only a small portion in the area. It should also be noted that there are no wells drilled in this area. In the BMM 28.1 area, there are 11 seismic surveys acquired from 1977 to 2011 that up to a length of 227 kilometers in the area. And in the area BMN 59, there are 11 seismic surveys acquired from 1976 to 2010 that up to a length of 510 kilometers into the area. And 2 seismic volumes, Mugrosa 3D and San Luis 3D, both cover a minimum percentage within the area. For Mugrosa, 29 square kilometers into the area, and San Luis, 9 square kilometers. The wells in the block BMM 28.1 has 7 wells, but most of them drill in the forest, being Brabal 1, the first well drilled in the area by Sierra Nevada Company, and reached a total depth of 2,812 feet. And the last was Tato 1 in 1962, reached a depth of 7,892 feet. This is Brabal 1, Tato 1, Luna, Camacho Rodan, San Pablo 1, and Culimba. All wells are all, but there are electrical records of them with the basic set. In the BMA 59 block, there are 13 wells, where 5 of them were exploratory wells, as Cascajales, Mugrosa Sur 1, Golosa, and Palmas, drilled by Ecopetrol. And the rest of the wells that are located in that part, in the central part of the block, were drilled in the 90s to prospect coal-rich shallow depths. These wells were drilled by Ecocarbon and Carbocoil. The near fields for each block, for example, for the BMM 91, the field closest for this block is Pital, Olivo, and Totumal, located to the southern part of the block, where the distance to the closest field is 32 kilometers, corresponding to Pital. These fields have produced from limestones of La Luna and Rosa Blanca formations mainly, and the cumulative production for Olivo field that is located in that part is 1 million barrels per oil and 3.7 BCFs until 2014. And the production of Totumal field until 2014 is 0.9 million barrels of oil and 304 million cubic feet of gas. The near fields to the block BMM 28-1 are Cantagallo, Yarigui, Garzas, Cristalina, and Santa Lucia, where the Cantagallo field produces from La Paz and Mugrosa formations, with a cumulative production of 218 millions of barrels of oil and 109 BCF of gas. This data is taken from 2015 from IHS. The Garzas fields produces from La Paz formations with cumulative production of 2.4 million barrels of oil and 535 million cubic feet of gas. The other fields are Cristalina and Santa Lucia that produces from Esmeraldas, La Paz Sur. In the BMM 59, the most important fields around this block are Opon and Lilia, Mugrosa, and San Luis. The first gas and condensate discovery was the Opon field with 36 million barrels of oil equivalent of recoverable reserves, and a cumulative production of gas in 2015 of 45.5 million cubic feet of gas. Lizama and La Paz are the producer formations. In the same contract, in the contract of ON, is the Lilia field. The Lilia produces oil of 30 degrees API from Mugrosa formation. The field nearest to the block is Mugrosa, that produced oil from Mugrosa formation with an API of 38.2 degrees ants and reeds that produce oil from Mugrosa Formation with 46 degrees of API. It is also notable that the block is very close to the most important fields of the Middle Valley. The Infantas field with 259 million barrel oil of equivalent of recoverable reserves. In 1926, the La Sira field was discovered with 645 million barrels of oil equivalent recoverable reserves. The summary wells of the blocks. In the block BMM 28-1, there are 7 wells drilled from 40s. The wells that have more information are Braval 1, Camacho Roldan, Braval 1, Camacho Roldan, San Pablo 1, Luna, and Tato 1. Braval 1, drilled by Sierra Nevada in 1941, it reached a depth of 2,812 feet. In tests, showed gas with light oil in different intervals. Braval recovered muddy with sweet water with heavy oil. Camacho Roldan 1, drilled by Richmond in 1942, and it reached a depth of 1,457 feet. It reached the Lizama Formation, but without tests. And San Pablo 1, drilled by Shell in 1942, the well reported, the company reported that the well had oil and gas shows in the lower Eocene. And Luna 1, drilled by Intercol in 1957, reached a depth of 8,500 feet. The real formation had sands with sweet water and the Chuspa sands with shapes in different intervals. And in these intervals, the sandstones were massive and interlayered with shapes. And the another well was Tato 1, located to the south of Luna, drilled by Intercol in 1962. The well reached the Umir Formation, and La Paz Formation consisted of massive sands interlayered with shapes. Is the description, the similar description to La Luna 1. For the block BMN 59, there are 4 wells. Cascajales 1, that it was drilled in 1976, and it reached a depth of 11,400 feet. The targets were Rosa Blanca, Paja, and Tablazo formations in the Cascajal anticline. This well drilled all the Cretaceous sequence up to Tambor Formation. 60 tests were carried out in Rosa Blanca, Paja, Tablazo, and La Paz. In the Cretaceous units showed gas, but were considered non-commercial. Due to the high compaction, the sediments had low porosity and low permeability. And the sandstones of La Paz Formation showed good permeability and some cases tar. The test showed fresh water. It was abandoned as a non-commercial gas producer, but it was classified as B3. Another well is Mugrosa 1, drilled by Ecopetrol in 1977, and it reached a depth of 5,407 feet. The tests, they tested in La Luna Formation, and the resource was salt water tests in Chorro group 2, and the results were saltwater gas shows where the gas bore a flame with a 10-foot height. And another well was Palmas 1, drilled in 1977 by Ecopetrol, and the TD was 11,564 feet. The trap was a structural closure against reverse fault. The targets were Mugrosa and La Paz formations, and the well was in the lower part of Chorro Group without being able to define the presence of Eocene basalt sands. The well had gas shows in different intervals during the drilling. In the formation test in the Chorro Group, there was oil production, 1.6 barrels for each 8 hours with an API of 40.6 degrees. It was considered non-commercial. And the most recent well drill on the block was Golosa 1, located over the Mugrosa fault, drilled by Ecopetrol in 2015, reached a depth of 3,530 feet. The trap corresponds to a faulted anticline associated to a fault propagation fault and the target the basalt sands of Chorro Group. Golosa 1 had regular gas shows in Mugrosa and Esmeraldas formations and poor oil shows. So Golosa well was drilled structurally low. Then Ecopetrol decided to do a sidetrack in 2014, reached a depth of 3,265 feet, where the main oil shows were associated to Chorro Group, but very poor. Esmeraldas had low oil production, but into tests recovered light oil with water formation, and the oil or the debris of the oil were 53 degrees API and 31 degrees API. And the other test was in La Luna formation as a secondary target, but the result was water. The seismic interpretation. In the BMM91 block, there are two types of plays. Due to the lack of information, these plays could be considered play concepts. This seismic line belongs to the Pailitas 2015 survey that crosses two basin domains, the lower Magdalena Valley and the middle Magdalena. And this is the part is Serranía de San Lucas. In the northern part of the block corresponds to an anticline structure, and a widest anticline structure that are affecting the Miocene sequences. At the same time, these sequences are controlled by the basement configuration. You can see the configuration from the west of the basement. The eastern part is defined by the truncation of the tertiary sediments against a high angle fault. And this line, this deep line is a B prime, shows the truncation against the fault and against the high basement. Eastern part is defined by the truncation of the tertiary sediments, and the basement starts to outcropping towards the northeastern, associated with Serranía de Perijá. Further south, there is a deep line, CC prime, and it corresponds a reverse fault that is generating an anticline fault where the Miocene sequences are being truncated to the east. This fault is lifting to the east the sequences and the Jurassic is outcropping. In the line, maybe this corresponds to the Eocene conformity. And below of this horizon, we can find the Cretaceous sequences. The another deep line that is outside of the block to the south shows the configuration of the Eocene and conformity, where the Cretaceous sequences are pinching out to the west direction, and to the east, the recent sequences are truncated against the high angle fault. The seismic interpretation for the block BMM 28-1 corresponds mainly a structural plate, and it is responds an anticline with three-way declosure against fault, and this is affecting the Esmeralda La Paz formation. This strike line A prime that is located here to north to the south, where the closure is controlled by reverse faults of northeast. And that is the closure. And this is the two-way time map of the top of Esmeralda La Paz formation. And this unit is overlaid the Eocene and conformity, and the structure is located at the north of Brabal 1, which is drilled structurally low. This sets a deep line near to the structure because there aren't more seismic lines or deep lines near to the structure. And it is showing the possible seal in the east-west direction due to intensive faulting. In the BMN 59 area, several structural plates are identified in this block associated to the compressive dynamic of the faults as La Salina fault system, Arrugas, and Mugrosa faults, where have been identified closures from the Esmeralda La Paz formation in thrusts and subthrusts. This deep line with the direction northwest to southeast is located here, shows a structure affecting the Esmeralda La Paz formation that consists of a subthrust with a closure area of 1,893 acres. This is a two-way time map of Esmeralda La Paz showing the closure against the faults. The other structure corresponds to the Golosa Deep. It's a structure affected by two opposite virgin faults that creates a closure in both sides of the faults affecting the Esmeralda La Paz formation. Is located to the north of Golosa 1, and this is the structure defined in the map. And it is affected by the Mugrosa fault and the other faults that creates the imbrication. In this deep line, located in that part to the south of the lead Golosa of Golosa, and this is the well Golosa 1, located in that part. In this deep line, we can see three different faults associated to the thrusting of Mugrosa and La Salina faults. It has been identified two closures. The first closure associated to the thrust located here in that part to the east of the line, and the Golosa Deep with target to same formation in the deepest imbrication. So it's more deeper, it's deeper than Golosa 1, and it's an imbrication that we can find the Esmeraldas in that part. And this play corresponds to a shallow soft thrust located in the northeast part of the block, associated to the thrusting of La Salina fault. The closure is given by the Esmeraldas La Paz formation against the fault. And the structure is located to the south of the well El Regalo 1, where La Paz formation had oil or 38 degrees API and gas. And after the analysis of the identification of the leads, we calculated the prospective resources and the volumetrics of the prospective resources for the area BMA 19-1, located in the most northern part of the basin, is 99.97 BCFs in total, considering gas by the location of the block. We identify two leads, and this is the areas for each lead. For the area BMN 28-1, there is one lead with 1,585 acres with prospective resources of almost 58 million barrels of oil. And the 4 leads, 4 leads were identified in the BMN 59 block, where the total value of oil in place is 862.8 million barrels of oil, and prospective resources 215 million barrels of oil. In volumetrics, we have a deterministic calculation for a total of 7 leads, 5 leads in total for oil and 2 leads in total for gas. The original oil in place is 862 million barrels of oil for the BMN 28-1 and BMN 59 blocks, and 2 leads in the northern area, BMN 19-1, with original gas in place close to 400 BCFs. We haven't performed any kind of probabilistic calculation. Then we have a best estimate of prospective resources of 107.8 million barrels of oil and 49.98 BCFs considering gas. And this is the location for the every block in the basin with the leads associated. As a conclusion, for the Colombia round 2021, the ANH will be offering 3 blocks located in the middle Magdalena Bailey Basin, BMN 19-1, BMN 28-1, and BMN 59. With an area of 214,415 hectares. The BMN 91 is considered as an emerging area because of the data limitation and its location in the basin. The BMN 28-1 and BMN 59 are classified as mature areas. In the 3 areas, there are available a total of 100.9 kilometers of 2D seismic. In the BMM 59, there are 2 pieces of 3D seismic volumes with a total area of 38 square kilometers. Only in 2 blocks, in these blocks, 12 wells have been drilled. The basin is divided in 5 different domains with 2 different structural sites, one associated with transtensional normal faults and the other one with thrusting and development of fault belts. The main reservoirs in the BMN 28-1 and BMN 59 blocks is considered the Esmeraldas and La Paz formations of mid or upper Eocene age, while in the BMM 91, the Neogene units are considered the main reservoirs. Most of the leads are in trend with existing fields in a proven hydrocarbon system, such as the case of BMN 28-1 and BMN 59. Shallow targets are one of the incentives of the offer leads that maybe has not been considered previously by the industry. Inside the areas offered by the ANH, 7 leads have been identified with a best estimate prospective resources of 107.8 million barrels of oil for the BMN 28-1 and BMN 59 areas, and 49.98 BCS for the BMN 19-1 area. Thanks for your time.
Thank you, Lina Maria, for that great presentation. I would like to thank all the people that have been here today for the presentation. We got a couple of questions regarding 2 ANH blogs. The first one is by Mario Prince. He asked basically where we can get the links for the videos that have been presented couple of weeks before. All of them are available in YouTube by the ANH profile. You can see most of them. As far as I know, I think the last one that has been updated was the Sinu one. I think it's left the Choco one, the lower Magdalena Basin. But as far as I know, they will be uploaded quite briefly. Regarding to the question by Felipe Vargas of what is a mega area for the ANH, it's basically a basin. However, we don't call it a basin because, for example, for the Caribe and Urabá, we got them merged. So we thought that it was more appropriate to call them mega areas instead of call them basins. And regarding to the question to the Elbert Ordóñez, that why the BMM 19-1, we got it as a TEA contract instead of EMP due to the lack of information. It turned out that we only could have a TEA contracts for frontier areas. We do some quantitative assessment for trying to classify all of the areas, and the BMM into that assessment was classified as an emerging area. So in terms of law things, we could not, unfortunately, classified or offered as a TEA contract. I think that's all of the questions. Most of the questions have been already answered by Cesar and Ivan during the presentation in the chat. The questions that have not been answered in the technical questions, we will then answer them afterwards via email. So thank you for all of our speakers. Thank you for Cesar Mora, for Ivan Olaya, and Lina Maria for the great presentations. I hope all the people that was today with us, all of them have enjoyed them. And thank you very much. See you next week with Upper Magdalena Valley.